Hello everyone. Welcome back to our daily stream. Hello Ransom. How are you doing? Okay, so today we are going to um go over some questions from yesterday and also solve a few questions today. Now I put together two questions for today. A question I was asked yesterday and one tree based question. So which is what we are going to do today. Funny enough, this question was a bit confusing. As you can see, I was trying to solve it here. I wasn't done, but I just had to start the stream. Otherwise, I'm running out of time. What did ransom stream? Why are there always five people? Is it because you're on other devices? Uh, well, I don't know. Um, maybe five people. I think five concurrent viewers is you know maybe some other people that are watching, including yourself. So yeah. Anyways, let's get started. I have a few um. So welcome, guys. I think we can get started now. So let's see. The questions from yesterday, what were there? There were three based questions, right? So I will link them back here. So let's bring back those questions. I think they were like in the trees data structure. Mm, okay, so I think I did sim tree, and let's come back here. Let me sim tree range some PST, and I was going to solve merge two binary trees, but I didn't solve them. I didn't solve it, so we'll look at that as well. Um, so let's see what we have. Please, again, once again, welcome to the stream. Please make sure you like and subscribe if you are here in the stream and you are interested in data structures and algorithm questions. All right, so let me get started with this one. So I saw this question yesterday, which was to determine whether two trees are equal. Now, when we are comparing trees, right, to find out if they are equal, it's usually um, two things, right? First of all, they have to be equal structurally, and the node values have to be equal. Now, structurally means the left subtree of one tree has to have equal nodes, equal leaf nodes to the other tree, and the same thing for the right subtree as well. So, as you can see, this tree here has one node on its left subtree, and this other tree too has one node, and on the left subtree, the second tree, and for the right subtree, it's the same thing, one node, one node. Now the node values here are also equal, which is the root has one and one here, two, two, right, three and three. So that is the way we can determine if two trees are actually equal. We have to find out if they are structurally symmetrical or equal, and also if in terms of their values, right, if they have nodes with equal values. So to do that, I'll come here. Let's see, we have some things on the screen, but no, let's scroll up and keep this like this. So to compare these two trees, right, we need to compare their node values, and by comparing node values we'll have to traverse the tree, right? We have to go down the tree on the left side and on the left side, and traversing the tree is done with a specific method. For now, I only showed how to do the pre-order traversal, which means we traverse the tree by visiting all the left node on the left subtree before visiting any right node on the right subtree. So we'll perform a pre-order traversal by traversing all the node on from the root node, right, and down to the left subtree, the last leaf node, or the leaf node at least, if you will, the leaf node of the left side of on the left side of the root node, and then we'll do the same thing for the right side. Now, while we are traversing, we'll need to compare the value of the nodes each time, right? So again, the traversal has to be simultaneous, which means while we are traversing from this place to this side, right, we are also doing it at the same time here. Where's my, hold on. Sorry, I needed to get my tablet to draw on the screens because my mouse is not quite good for me to do that. So we go in different directions. So we go from here to here, and we do the same thing in this case. And while we are traversing the tree, with a pre-order traversal method, which is also known as depth first search, DFS, we compare the node values, right? So in this case, we'll compare 1 to 1, right? And then we'll continue the traversal on this side, and we'll do the same thing here, and we'll compare this to this, which is equal. Then we'll come back to this side, we'll traverse the tree on this side as well, and we'll compare these nodes at this point, right? And by the time we reach the leaf nodes on each side, we will terminate the operation. We will stop iterating or traversing the tree. So in this case, if we've seen equal node, it means the tree, both trees are equal, and by equal, they are equal structurally and in terms of their node values as well. Okay, so that is one of the things we'll be doing now. I'll go over the code again. We'll perform. I'll write out the code again. And show you how it is done. So there are some few cases where we need to, continue the traversal, which means the trees have to have the same amount of nodes, and traversing the tree is done with a pre-ordered traversal method. That's what we are going to do now, and it involves recursively calling a function, and by passing its different value at each point of the recursive call. So we will do that now. I'll open my code editor. So here is something I was doing before, but let's come back here. You know what, let's do it here. I'll open a playground. So here is a function that I did yesterday. This is like an overview of how trees work, how we insert nodes in a tree. And here is an example of a pre-order traversal. Now the pre-order traversal was done in this form because I wanted to return the results, right, of how the nodes are inserted or traversed in the tree. So if you want this, if you want to learn about trees, you can go to the GitHub repo in the link below, and you will have access to um, this. So you can look at the trees folder. There's basics and everything I've done so far: insertion of nodes, creation of nodes in a tree, right? You'll see all of those. So this is a result, pre-order traversal, right? There's this as well. And yeah, so basically this is all you will see when you come to this file, and you'll be able to learn about trees, how to insert node in a tree, how to traverse a tree with the pre-order traversal, which is also called the depth first search. Okay, so enough of that. Let's pass on to our solution. I'll come here. As usual, when I repeat a question, I usually put it in the repetition folder, which means I've solved this question once again, and also it helps you solidify your understanding of the question. So when you solve a question for the first time and you get it, you are required to solve it once again in order for you to truly understand the question, at least to be able to retain part of it. Otherwise, if you solve it once and you don't solve it again, even though the question is an easy question, you will struggle to solve it the next time. So I usually do this to to remind myself how many times I've repeated the question in order for me to be confident about it more. So let's go. I'll create this file. So this is going to be lit dash what number of question is this? 100. So lit code number 100, and I'll set this to same tree, right? Same tree, and I'll call this repetition 1, right? So this is the first time I'm repeating this question. All right, so we are given 2 trees and we want to compare the trees, right? So here we need a boilerplate for the code, so I'll just quickly copy this part. Where is this? Same tree. Okay, so I'll copy this part of the tree question, then paste it here. I'll comment this out, right? Remove this part here like this. Sorry if you are not seeing this. I'll show you what I'm just doing. I'm just trying to set up the environment to solve this question. So I'll remove this as well. Let's format the file, and yeah, so right now we can just come here. I'll bring this back, and we have this. So this is our input. We are given to input at least two nodes, right, from a tree, and we want to compare if they are equal or not. All right, so since we are going to do a pre-order traversal, it means we have to traverse the left and right node at the same time. I mean the left node of each tree, right, at the same time. The left subtree, sorry for a lack of better word, the left subtree of each node, of each tree node, right, at the same time or simultaneously. So our recursive function is going to be called and be passed those values, right? So we'll pass it the left subtree of P and the left subtree of Q, and then we'll do the same thing for the right subtrees. So what are the conditions that will make a tree to be equal? Well, if P dot if P is none, right, if both tree have reached their root leaves, so we can say leaf nodes, then we can say for sure that these two trees are equal. So if P and Q are none, right, P and Q is done, then it means these trees are equal. So we return true. Now, what are the conditions for them not to be equal? So we can say else if P, right, if P's value is not equal to trees, I mean if there is a P node, so if P is none, right, if one of them is none, then it means they are not equal, right? So let me just give some space here. What is this error now? P is same. This code is unreachable. Why is that? Alright, that's not really a problem, so let's leave that for now. So if P, right, is none and there is a value for Q, then it means they are not structurally equal, right? So we can say P. So in this case, we did if P and Q are none, then it's true, they are equal, right? But if P is none or Q is none, then we can say they are not equal. So is none, then we can say just return false, right? Return false, and their values have to be equal as well. So we'll say else if P dot value is not the same as Q dot value, right? Q dot value, then return false as well. Return false. Okay, so these are the conditions for us to determine if the trees are actually equal. So the next thing for us to do is to so I'll say return. So we'll recursively call the function, right? So we'll say return self dot same tree, but this time around we have to pass it the left subtrees of each of the trees. So we'll say P dot left, right, and then Q dot right. Okay, sorry, Q dot left as well. Q dot left, and so when the call on this side, right, passes all these tests, maybe this return true, right? We need to find out if the right hand side or the right subtrees are also equal, right? So say self dot is same tree. Now by doing something like this, we are traversing the tree for the left side first before traversing the right subtrees. This is pre-order traversal or depth first search. So we say this here, we say P dot left, sorry, we are doing for right now, P dot right and Q dot right, Q dot right. Okay, so this is what we'll have. The function will be called here, right? And in this case, if this return true, if this portion of the recursive call returns true and this part also returns true, then the entire thing will return true. Otherwise, if one of them returns false, then it means we are going to get false. The trees are not equal. So we can run this code in LeetCode and see. Let me remove this part. I think we literally have the same thing now, but you know what, for the sake of testing, right, let's just do it. I'll replace what we have here previously by with the new implementation. So I'll just copy this part. Okay, so here's what we have. When we run this code now, you see, um, we'll get some. Okay, I'm not sure why this is taking long. All right, that took a bit of time to finish, but anyways, the test cases have been passed. When we submit this, you'll see this solution actually works. Um, One thing I have been forgetting to do is to actually find out the time complexity of a recursive function. Now, because we are calling the function every time, I imagine, and also we are passing it, different parameters. It means we are traversing each node for the tree, right? So it's going to be the amount of nodes we have in the tree, and this is going to be O of n, in my opinion. Otherwise, maybe it could be something else. So I think I made the submission of the same question. Like I said, this code is not really consistent with their rating, so don't really beat yourself about this, right? As long as you understand the problem and you're able to solve it, um, it's a win. You can actually improve on it later on, right? So let's find out this part. I'll copy here. I'll open this. Um, so I can't. Okay, let's just do this. Git add. Git commit dash m. Um, we can just add this here. So this is going to be tree dash. Okay, binary search tree. So I'll say BST, and the question was leads code, leads number 100. So we'll do it this way. All right, so let's move on to the next question. The next question would be on the list today is a question on tree, right? So we'll do that and then solve one of the questions I was asked yesterday, which is to solve this question. I think odd string difference. Now I was trying to solve this question earlier today. I thought it was just a typical question on strings, but you needed to be careful with this question. But we'll look at this now and we'll solve this as well. So the next question we have on the list now is to merge two trees, right? Now as you can see, I have not solved this question and we will solve it now. So to merge two binary trees, so let's say you are giving two binary trees, root 1 and root 2. Merge. Imagine that when you put one of them over the other, some nodes of the two trees are overlapped while others are not. You need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then sum the values up as the new node value of the merge node. Otherwise, the not null node will be used as the node of the new tree. Okay, so this is another interesting question. So note, so you return the merge tree, and the note is the merging process must start from the root node of both trees. Again, we are going to traverse both trees simultaneously, and then so let's take a look at this. I'll bring this here. Oh, I forgot to check if there are any questions for the previous question. Let's see. Hello, Dan. Hello, everyone. All right, so currently there are no questions, so let's go back to our. Okay, I was going to do this. Okay, so let's take this part. So here's our question, and we want to merge two trees into one tree, right? So there are a few rules. The rules are such that we need to sum the nodes of the tree where they overlap. So in this case, the root of each tree is going to overlap. So we can say the root of the merged tree will be equal to 3. Will be equal to 3. Sorry. So this is 3 here, and it's just weird saying 3 and 3 at the same time, right? Okay, so that's a mouthful anyway. So when we look at these trees, right? When we look at these trees, here we have the nodes, the root node of each one of them. Again, we are going to use a depth first search to traverse both trees. Um, at least that's the only method I know for now. So we'll use a depth first search. We'll traverse both trees and we'll return um, a new tree from both of them, right? So we merge both trees. So I'll write out I'll just draw our merged tree here. So this is what we are going to return at the end of the day. So this is our merged tree. We'll start from the roots. Now when we are traversing both trees, we'll have to start from the roots, the root nodes. So meaning here we'll find out if the roots overlap. Obviously, if both are trees and they have some values, they'll probably start from they are likely to start from the root node, right? So we are going to add the values of the root node. What did I just say? I think any tree at all, right, with nodes in it have a root node, right? So there is always a root node in a tree as long as the tree has values, right? Without the root node, you can't add nodes to the tree, right? So we always have the root node. So we'll make a recursive call to traverse both trees simultaneously, and we'll start from the root node of each tree, right, which is here. So for the first tree, we have 0, we have 1 as the root node's value, and the second one has 2. So when we merge these values, right, which is 1 and 2, we'll get 3. So here is 3, and then we continue with the merge. So the next node, let's put it like this. I'll just come here. This is going to be 3. Okay. The next, so we go this way, right? We traverse the left side. So the left subtree is here. So we go in this direction. Sorry, let me properly trace that. We'll come to this side. Now we add these two values, right? So this is going to be equal to 3. 3 plus 1 is 4. So we'll have 4. And then we go this way again. Now this node here does not have a right child, right? A left child. So we'll just add the left side of this node, which is the left node, which is 5. So this is going to be like this, and we'll add 5 here. Then we want to traverse the right child of this node, but this node does not have a right child. So we have 4 here, and we add 4 to this side here. Now this is very weird. Normally, you can't have equal values of node in a tree, but anyways, this is just custom to this question, so don't be confused about this. So the next thing we do is we continue with our pre-order traversal. Sorry, I need to remove that. So this is going to be 4, and then we continue on the right subtree of the root node. So the right subtree of the root node, we have 2 and 3, so this is going to be 5. Then we continue, we check whether this node has a left subtree, but it doesn't, so no left subtree for now. We stop and we check for the other one. This one too, the other one does not have a left subtree, so we continue on the right. No right subtree, but this one has a right subtree. So yeah, so the right node of this node here is 7, sorry, 3 is 7, so we add 7 here, so this is going to be 7. And with this technique, we've merged these two trees into a single tree. All right, so let's pass on to the solution. This question is what question is this? Number 617. So let's do this. I'll say leads code number 617. Leads dash 617 merge dash 2 dash trees. Okay, so we can merge two trees. All right, let's copy the boilerplate code. I'll just copy this part, and then we can paste this here. So we just clean up the code for now. We just clean up this part. Let's remove this, let's remove that. Okay, so this is how our tree will look. Our solution, I just cleaned up everything and we can get started. Now, one trick about recursive calls, or traversing trees with a recursive call, recursive function, is to define what the outcome will be at the end, right? So let's say, for example, because we want to merge two trees, we'll assume first of all the root 1 and root 2 are the only nodes that we have, right? For now, these are the only nodes, and we'll work with root 1 and root 2 to create a new tree, right? So here's what we need to do. We'll say if root 1 has a node, right? So we know, okay, so let's do it this way. We know both trees have a root node, right? And in some case, while we are traversing the tree, right, we'll reach a point where there is no node in a particular spot, while there is a node in of one tree, and while there is a node in the spot on the other tree. So meaning they are not equal at that time. But in the case where we're at the root node, it means there are two values at that point. So I'll create a merged node, or I'll call it merged tree, right? Merged tree initially is going to be a node, right? A tree node. So we'll say tree node, right? Tree node, and then we'll add the values of these two nodes here. We'll say root 1 plus root 2. So root 2 here, right? So root 1 dot value, root 1 dot value plus root 2 dot value, root 2 dot value. Now this is what we need to return at the end. We can just say return merged tree, right? Now we are not done. This is not the full thing, but this is an idea of what needs to happen. We still need to go through the whole process of traversing the left subtree of each tree and then the right subtree of each tree. So we can say if the root 1 is none, right, is none, then return root 2, return root 2, root 2. Otherwise, else if root, so you can just say if not root 1, right? Or if root 1 is none. So let's just do it this way. If not root 1, then we return root 2. If not root 1, then we return root 2. Else, if not root 2, then we return root 1. So return root 1 like this, root 1. So meaning, when we get to this point, right, we merge the three nodes, okay? And if there is a value for our, when we get to a point where there's a value for the root 2 and root 1 is none, then we just return root 2, right? There is no need to run this merge here. Otherwise, if they both have values, right, then we can just continue with the merge here and return the merge. Okay, so that's the build up process for our recursive function. So the next thing we need to do is to define some other cases, right? After creating this node, right? And this is the point where we need to recursively call the function and perform all this all this operation within the recursive calls. So we'll say merge tree. Now we need a left subtree for our new tree and a right subtree for our new tree. So we'll say merge tree dot left, right, is going to be equal to merge trees. So we'll say self dot merge trees, and we'll pass it the left and left of both trees, right? Left of root 1 and left of root 2. So this is going to be root 1 dot left, right, and root 2 dot left. Okay, and we'll just continue with this. So now one thing you imagine is you might be wondering about is the root of this merge tree, and to answer your question, the root will simply be the first operation we did here, right? So this is going to be our root, and the left and right will be added at this point. So we'll do the same thing for the right node. So we'll say merge tree dot right is going to be equal to self dot merge trees, and you'll pass it the root 1 dot right, and then root 2 dot right as well. Okay, and yeah, so this is all we need to do, and then we'll return the merge tree at the end, right, at the end of these operations. So here's a trick. When you want to recursively call a function, it is best to define all the base cases, right? The base cases to continue the recursive call before you start recursively calling the function, right? And in this case, when you look at this function here, we actually define the cases for us to recursively call the function. So in this case, if we reach the leaf nodes of P and Q, we return true, and then we stop the recursive call of the function. Otherwise, if one of the trees have a value, right, or one of the trees have nodes and the other does not have a node, at that point we return false. Otherwise, we return false for the value of the node. So we compare each node's value in P, right, and in Q. So yeah, this is one thing I've realized about recursion. So you really need to define the base cases before you start recursively calling the function, right? So again, here's an example. So if any of these cases are not met, or if any of these conditions are not met, then we continue calling this function until we get to a point where this becomes true, right, or this becomes true, or this becomes true, right, and then we stop the iteration. So that's one thing. And the same thing happens here, right? If the root node, if not root 1, then we return root 2. So if there is no node in root 1, or at the point where we get to a node in root 1 and we don't have the corresponding node in root 2, then we return root 1, and the same thing happens here, right? Otherwise, we just create a node from the merge tree, and then we set it as the root node. Then we set the left side of the merge tree that we are going to return at the end of this function, as the left node, and we recursively call and pass it the left subtree of each root, right? So root 1 and root 2 in this case, and we do the same thing for the right subtree as well. So let's run this function for now and see what we get from LeetCode. So I will remove this part. So here's our function. Let's run this and see. Okay, so the test cases have been passed. So we run this function and submit. And you can see this solution is quite okay. So the solution works. So I'll push this to GitHub, and in case you want to see how I did it, then you can just have access to it there. So let's just add this git add. So it's still the same thing, binary search tree, but this time around is question 617. All right, so that has been committed. And let's move on to the next question. The next question is on strings and arrays, and strings and arrays. Well, I'll put it in strings and arrays here. So this is a very interesting question, and I'm not sure if this question is actually easy or not, but it took me quite some time to actually understand this question, right? And I had to also read some of this thing here. You can see it's still open. I had to read some of the explanation here to actually understand what the question is saying. But anyways, I've done the difficult part, so I'll explain what I found. So let's create a file for this question. So this is going to be LeetCode 2451, right? 2451. Okay. So this is number 2451. So leet dash 2451 dash what's the question name again? Odd string difference. Okay, so odd string, I'll just put odd string, odd dash string. Okay, so here's our odd string, and we'll just copy this part of the question. There's not much inputs. Anyways, we'll walk through together. So let's read the question and understand what it is. So here is what we are given an array of equal length string words. Assume that the length of each string is n. Each string words at I, right? I being the index. So it's going to be it's going to start from 0 all the way to, the length of the words minus 1. So I being the index can be converted. So each string words I can be converted into a difference integer array. Difference at I of length n minus 1, where difference at I at j is equal to words at I j plus 1 minus words at I j, where j is less or is superior or equal to 0, less or equal to n minus 2. Note that the difference between two letters is the difference between their position in the alphabet. That is, the position of A is equal to 0, B 1, and Z is 25. For example, for this word string ABC, the difference integer array is 2 minus 0, 1 minus 2. And this is the result of this difference, 2 and 1, negative 1, sorry. All the strings in words have the same difference integer array except one. You should find that string. Return the string in words that has difference integer array. Okay, so this is a mouthful, and it's a quite um at first you have to, like, I don't know, I like I said, I had to, like, look into this part and understand what the question is really about. Anyway, if you understood this at a goal, then that's awesome. Right, so let's see what the question really is and how I understood it. So that we are given our input is words, which is a list of words, and we want to find the difference of each word, right? And return the difference as an integer array. Now, the difference has to have a length of the entire word, right? Array minus 1, right? Which is n minus 1 in this case. Or you could do, the actual word n minus 1, which is this case here. Sorry, not the words, it's the word itself, right? So let's come here. I'll take this words array, I'll copy it like this, and we can paste it here to see what we have. So this is going to be like this. Let's change the color to a white one since it's an input. So yeah, so we have our words like this. Okay, I think, who asked this question yesterday? It was somebody, I don't remember their name. Um, uh, Anyways, I hope you come, you know, to see the solution today. All right, so we are given the words like this, and we want to find the difference of each word, right? So the difference of each word is going to be the we are going to subtract each the position of each letter from the previous one, right? So in this case, for A, B, or this is D, right? A, D, C, right? A, D, C is going to be equal to, here we have, so let's take a look at the how the difference is found. So the difference here of each word is going to be word at I, right? Minus word at I, which is the first word. For the first word, we are going to do J plus 1 minus J. So the first word, the first letter minus the second letter. So in this case, A here is 0, D will be 2, and C will be A, B, C. Sorry, let's do it this way. A, B, C, D. So this is 0, this is 1, this is 2, this is 3. So here we are going to get 0 here. This is going to be D is 3, C is 2. So we'll do something like this. We'll subtract the word after the first one, right? So you subtract from the previous word, the current word from the previous word. So let's say we do D, right? D minus A. So this is going to be D minus A and C minus D, right? And this is going to be equal to D minus A is 3 minus 0, and C minus D is 2 minus 3. This is going to be equal to 3 negative 1, right? And we'll do this for each of these words, right? Each of them. And the question says there is one of the words in this words array, right? One of them. So let's assume all of the words have the same differences, right? So let's say for WZ, Y, this is going to be equal to 25. Now the reason why it's 25 and not, okay, so Z is 25, right? So Z will be 25. W, what's W again? A, B, okay, I can't count that now. So what's W? Come on. So if Z is 25, so this is 25, 24, 23, and 22. So this is going to be 22, and Y is going to be 24. 24 like this. Let's erase this part. Okay, Y is going to be 24. So let's find the difference between each one of these. So we'll just do something like this. Again, we'll repeat the same process here. So we take the second word, right, subtract the first one, the one before it, right, that will be our first word, and we'll do the same thing. So we'll subtract Y, we'll subtract Z from Y as well. So this is going to be here, this is going to be, what's W? Z minus W is going to be Z minus W, 25 minus 22. So 25 minus 22, this is 3. So we'll put the 3 here. This is 3. And Y minus Z, Y minus Z, Y is 24, Z is 25. This is going to be 24 minus 25, negative 1. So we'll do the same thing for A, B, C. We'll have A, B, C. A, B, C is equal to B minus A will be 1. So B is 1, A is 0. And C minus B is going to be 2 minus 1 is 1. So here is our differences, right? So we have negative 3, negative 1, and 1 to 1 in this case. So the three differences we have are the ones I circled in blue, right? Now the question is asking us to return the difference which is not equal to the rest. In this case, we have so let's return the string in words that has different integer array. So different integer array simply means, so in this case we have negative 3, we have 3 and negative 1, 3 and negative 1. So we want to, the dominant one here is 3 and negative 1. This is the most frequent one, or the one that occurred the most, the difference that occurred the most, right? So the difference that occurred the least in this case, which is once, right, the difference that occurred just once will be the difference of the integer array that we need to return, right? So we have to find the string that gave us this difference, which is 1 1, and then we return the difference here, which is A, B, and C. So this will be the returned value of our function, right? Now the trick to this question is to, I mean, one of the I would not say difficult, but like one of the interesting parts of this question is how to determine the index value of each character, or the value of each alphabet letter, right? So I was doing my research today before this stream, and I found that you can use an ORD function in Python to get the value of so you can see when you pass ORD of a function, sorry, when you pass a character to ORD, it will return the Unicode of that character, right? So the Unicode value of that character. Let's try out this. I forgot to show. Let's say we did something like this. So first of all, we need to do print ORD. Come on. First, ORD, yes, ORD of A. Now this is 97, right? Okay, this my I don't know, freak you out a little, but the point is every other number, right? When we try to get their Unicode value, it's going to be different, right? At least it's going to be bigger. So here it's going to be 98. Now you can see A was 97, B is 98, C, what would C be? I think 99. You can see, so it follows a specific order. So with this, we can simply perform our subtractions and get the difference at each point. Now, the steps to solving this question is to first of all get the difference of every value in the word array, right, or in the word list, and then find out which difference did not occur the most or just appeared once, and then we return that difference, the word for that particular difference. So let's do this. I'll take this here. Oh, come on. Okay. um so we'll first of all create an array. I'll call this the differences. So differences is going to be an empty list, and this is where I will append all the differences we found, right? So anytime we see a difference, I will append it to this word, this differences array. So we need the length of the first string, right, of all the strings in word. Since they are equal string, we can just work with one, right? So this is going to be n, right? As the question says, this we should assume you are given an array of equal length strings words. Assume that the length of each string is n. So we just put n here. We say n is equal to the length of the word, right? Word at 0. Okay, so we'll get the first word's length, and then let's just put the length of the word itself. So I'll just say word length, because we are going to iterate for each word here. So you know what, we can just leave it like that and we just use the word. All right, I'm tempted to do this. So length, or let's say, yeah, length of w words, like this. So I'll just put a small comment here after that. This is the length of the words, right? So we can iterate for every string in the word array or in the word list. Then we find the difference for that string, right? So we can do something like this. So for I'll call this for I in range. Why am I typing like this? For I in range of m, right? Of m, then we can just say, so we need to create a difference array, right? Oh my god, I did not check the chat to see whether there are any questions. So I have lightnings on this, so it's nice. What's your typing speed? I don't know. I've not found out my typing speed yet. I don't know. I'm probably slow, yeah, or maybe average. So my microphone is on my face. So let's say we get the difference, right? So I was solving this question earlier at this point, but let's continue with this part. So we have for every, so I want to get every word here. So this is going to get the index of every word in words list, right? So with this we can get the first word, the second word, and so on. So we'll do something like this. Say for word in word, so we can say this is going to be equal to, we need an array to a list to keep the differences, right? So I'll call this temp difference, just call this temp diff, right? This is, or just leave it as temporary, because this will be reset, this will reset every time we iterate with this loop. Right now we are going to use a nested loop, so sorry about that. This is going to be j, right? So yeah, so with this we can do something like this. We say for j in range, now we want to iterate, we want to iterate for every character in the word, right? In this word here, so words at I, right? You can see the difference at I and j is word ij plus 1 and minus words at I j. So and j is the length of the word, is between 0 and the length of the word minus 2. So we can say j will start from okay, so it's going to be range, the length of the word minus 2, right? So we can say range of n minus 2. So this is going to be the word. And yeah, so we say temp is going to be equal to, now temp is going to be, we want to append to temp the current difference, right? And to find the difference, so let me write a variable for the difference here. I'll just say diff is going to be equal to words. So we take words at I, which is the first word, and then just like the question says here, so word at I, word at I at j plus 1 will do the same thing. Word at I at j plus 1, right? Then we'll do minus again, we'll do the same thing here, word at I. So let me just copy this. This is the same formula we are going to use. Now as you can see, in this case this will return a string, an alphabet letter, right? And we want the actual value of that alphabet. So like I said, we are going to use the ORD method, which will return the Unicode value of that character, right? So this is going to be, here we'll say ORD, right? We'll put this here and then we'll do the same thing here, ORD, right? And now you can see the warning is gone, and then we'll just append diff here, right? And then after finding that diff, then we'll just append that diff to our differences array. So differences dot append the temp here. So let's print the differences and see what it looks like. So print differences, and we'll use the first test case to do this. So I'll say my solution, right? My solution is going to be equal to the solution class, like this. And then we'll say, let's call my solution dot odd string, and then we pass it this array here. So we use this one, words like this. Yeah, we only have one input, right, for this question, so we'll use this. So let's print this and see. Now you can see we have 3, 3, and 1. Okay, this is strange. Why is that happening? Range n minus 2, right? Now if you do range n minus 2, we'll not reach the last one, so we can just do minus 1 instead. So now we have the values here. All right, so this is good. The next thing we need to do is to find out which one of them occurred just once, right? So with this, we can use the count function from the list method, right? So we can just do something like this. We can say for every difference in the differences list. So for D in differences, so let's say in range, the length of differences, right? Then we want to find out which of the differences is equal to 1. So we can do something like this. You can say if differences dot count the differences at D, right, is equal to 1, because the count, let me show you what the count does. I'll use this, I'll create an array, right? Let's use the playground. So this is the playground file. I'll remove everything here, right? And I'll create an array called nums and say this is equal to 1, 2, and then I'll put 1 here again. And I'll say print nums, right, dot count the first. So let's say count how many times there is 1 in this array. So which is what this function is doing, right? So we can say count nums at 0, okay, and you see this will return 2. So let's print this. Now you can see we have 2 here. So this is how many times 1 appeared in the nums array. So we'll do the same thing if we wanted to find out how many times 2 occurred. 2 is at index 1, so we'll put 1 here, and then we'll run this again. Now you can see it only appeared once. So it means the function that, the array, the difference that appeared only once in this array will return a count of 1 here, right? So we'll simply do return. If we found that value, we'll just return from the word string. We want to return that actual string, right? So we'll say so words, so we'll just do words at index D. So we'll return it like this. Are there any cases where there won't be a word, so that we can return something else? So consist of lower cases here. So the word's length and dot length, let's see, all string have the same differences integer array except 1. Okay, so there is always one string that will have a difference integer array. Okay, so we can try this out and see. So again, let's see what we have here. I'll post this. Okay, let's run this function and see. Okay, we've passed 2 test cases. Now let's submit this again. Okay, this solution is quite slow because first of all, this is O of n squared time complexity. I can just say maybe this like a brute force solution, right? So there's room for improvement, and we'll look at the improved version tomorrow. Okay, my time is up now. I'll commit this code. Even though we passed the test cases, it wasn't quite maybe a way to do this is to actually use so iterating like this, well, maybe you can use a dictionary and get the, all right, I don't know yet. We will look at the improved version tomorrow. So let's commit this for now, and tomorrow we'll look at an improved version of the solution. So git commit, we're saying, so this is strings strings dash arrays, and this is lit code dash 2451, and then we do git push origin main. All right, so the solutions have been pushed now. Yeah, so we'll continue tomorrow. Yeah, so time is up. Thank you guys for watching. Let's see if there are any questions. No questions. All right. It's been great streaming today. Thank you all for being here, and I'll see you tomorrow. Bye.